So what I'm doing here is going to show you how to connect two Arduinos together with using the RS232 cables. So there's the cable in between them. You can see an Arduino at the far desk and an Arduino at the close desk here. Okay, so what we've got is I'm connecting the transmit on one of the pins of the Arduino to the yellow one and the receive on one of the other pins to the pink one. And what I have here is a program that uses the library software serial. So the reason why we need to use software serial is because the built-in RS232 in the Arduino is really used for connection with the PC and to send data to and from the PC and to program it as well. But what we want to do is, besides sending data to and from the PC to the Arduino, is we want to have the Arduino connected to another Arduino. So we really need another communication port. So software serial is a library which will allow any other pins to be used as RS232 ports. And you can just about see here that we've got software, includes software serial, then software serial, my serial. So pin 10 becomes a receive point, RX, and pin 11 is now a transmitting port. You can use any pin within reason, but these are the ones that I've set up here. So RX is pin 10. So let's have a look at the Arduino. So we have pin 10 is the black wire. So that's receive, and that is connected to the pink wire there. So pink is coming in and that's receive. And then pin 11 is TX, transmit, and that's the wire here, the brown wire, which goes to the yellow wire. And then we have the black wire, which goes to ground. We always need to have a common ground. Okay, so let's trace the wires through. Let's look at pin 10, which is receive. So pin 10, receive, goes to a pink wire. So remember, we've got receive on the pink wire. Over to the other one, we've got the same program running on this second Arduino. So what we have is the pink wire, remember it was receive on the other one, is going over on this wire here to pin 11. So that's transmit on this Arduino, goes round to receive on the further Arduino, and vice versa. So we have transmit and receive swapped over on this Arduino. So, okay. And that's all we need to connect two systems together. Now, using the picoscope, you can actually look at that data. But what I'm going to do now is just show you this program running, and I'll just take you through this program briefly. So in the setup, this is where we've set up the baud rate, so it means how fast is the data. And you'll see that there's two serial begins. So the top one is serial.begin 9600. That is actually sending the data from the Arduino to the PC through the USB port. And it also sends data from the PC back to the Arduino through the USB port. So that's the top one. So serial.begin 9600, that's the rate that will be using. Then my serial.begin, I'm using a lower baud rate, 4800. Now that is only used to communicate between this Arduino and the other one. So the data through the lines here will be at 4800 bits per second. And the data from the Arduino along the USB cable to the PC will be at 9600. Why have I chosen those values? Well, I've chosen two different values just to highlight, they could be both the same, but just to highlight the difference and just to make it clear that there's two separate communication channels going on. In the main loop of the program, it's quite straightforward. It just does two things. The first one says, if there's some data which is available, then print it onto the main screen of the computer. What do we print on the main screen of the computer? We print the data that we've just read. So the first line there says, if there's data available, then serial.write, which means send something to the PC. And what am I going to send? Well, I'm going to send whatever I read on the RS232 port. The next line down says that if serial is available from the PC, so if I'm pressing a key, then write whatever I've pressed onto the my serial port, and I'll read whatever it is, the key that I've actually pressed. Okay, so 2 bits of that program. Let's see it in action. So upload it, pressing the upload key, and then you can go into serial monitor to see the data. So I've just opened up serial monitor. There we go. I'm just going to upload the program. Remember, it's the wrong program. And I'm going to do that on the other Arduino as well. Okay, upload onto both of those. So this one is uploading data to this Arduino here, and I've just done the same on the other computer. So it's just compiling it and uploading it. Once it's uploaded, I can open up serial monitor. Okay, and at the moment we see nothing. Just go over to this one. This one has done uploading as well. Okay, and at the moment I see nothing. So if I send data here, you'll notice that the baud rate, by the way, is 9,600. That's because this is communicating through the USB cable to the Arduino. That's why it's at 9,600, because it's the serial write, not the my serial write. Okay, so I'm going to send this data by clicking on send. Okay, and it's gone. So it's been sent to the Arduino. Then the Arduino has said, oh, there's data coming in on the serial port, which is connected to the USB at 9,600. I'm going to read that data and then send it at 4,800 through these wires to this Arduino. This Arduino has said, there's data that's just come in. I'm going to read that data and then at 4,800, because that's the wire, the my serial wire, and then transmit it through the USB cable up to the PC at 9,600. And you can see, as if by magic, there, it's been received. It's been received, there you can see the baud rate. So, and this works in both directions because we've got both TX and RX. So I can enter that, press send, and on the other side, the data's just appeared. Of course, it's better if you can see it both in real time. It's very difficult to capture it on the screen. Okay, and that's the first part.